Welcome and hello to everyone. So today I'm going to present to you about our SolidWorks mini project, which is wind turbine. This is our group members. First of all, we're going to the introduction. I would like to present about the wind turbines overview. Wind turbines can generate electricity by converting wind's kinetic energy into electrical energy. It can produce over 650 gigawatts of power annually. It also can be classified as renewable energy, reducing fossil fuels reliance and greenhouse gas emissions. How wind turbines works? First, the wind turbines use the aerodynamic force of rotor blades to capture wind energy. The wind flow causes blades to rotate due to the pressure distribution. After that, the gearbox spins a generator to produce electricity. And the transformer converts all the electricity to voltage for storage or grid distribution. There are three applications of wind turbines. First is powering homes, residential areas, and industry. Second is pumping water, and third is producing hydrogen. Next is the design and analysis. We designed the wind turbine using SolidWorks 3D CAD software, and we perform finite element analysis (FEA) to predict body behavior under load and boundary conditions. And third is we're using FEA to help reducing physical prototypes, optimizing design components, and simulate physical phenomena effectively. So we're moving to the design part explanation, which I want to explain each of the design part. First is the base. Base is onshore wind turbine base plate provides strength and durability to withstand wind forces. For the features, the central hole that was cut using extrude are used to hold the wind turbine tower for stability. The 4 bolt holes on the side to secure the base and improve stability during strong winds. For the benefits, it can increase stability, durability, and efficiency in generating electricity. Second is the rotor. The rotor hub connects blades to the main shaft of the wind turbine. For the features, it has 3 rolls from cut extrude on the sides to hold the blades. Second is 1 hole at the back to connect the rotor hub to the nacelle. And third is F-hole shape for improved aerodynamics. It created using the revolve feature. Third is the blade. Rotor blade is the key component for converting wind energy into mechanical energy. The features is F-hole shape, improves aerodynamics and structural durability, and it also designed to optimize airflow, enhancing energy conversion efficiency. The fourth is lower Mars, and the fifth is upper Mars. For lower Mars, it supports the turbine and connects to the base plate. And it also designed to be taller and larger diameter than the upper mass for optimal design and cost reduction. For the upper mass, it used to connect to the lower mass, rotor blade, and nacelle. It also built a tall, slender steel structure for monitoring wind, speed, and direction. And the sixth part is part of the drivetrain, also called the main shaft. It connects the rotor to the gearbox and generator, and it also operates at low RPM, 30 to 60, with high torque. And next part is the washer. Shaft bearing designed to reduce friction and extend to the turbine's lifespan. The 2 bearings are housed to improve efficiency with a diameter of 22.87 millimeter. And the last part of the design is housing, which also called nacelle. It covers and protects components such as the generator, gearbox, and drivetrain. It also designed with 2 holes to hold the shaft bearing securely. And this is the final model of our project, which is after it all assemble all parts into a horizontal axis wind turbines, hooked with 3 blades. The design was chosen for higher efficiency. Blades and the blades also move perpendicular to wind flow, enabling efficient energy generation. For the dimensions, I stated the head and the rotor blade length. Meanwhile, for the purpose, the larger size design to generate more energy. For the design iterations, the first is brief, which is we define the goal of designing a functional wind turbine using SolidWorks, and we establish requirements such as head, height, blade dimensions, and efficiency. Second is analysis. We research wind turbine components and their aerodynamic properties. We also study the efficiency and advantage of horizontal axis wind turbines hot. Third is the design ideas. We brainstorm together about the different design for parts like the base, rotor blades, and mass. Next is we also consider airfoil shapes and structural durability to maximize performance. Fourth is modeling, which we create a 3D models of all components from base, rotor blades, and mass housing in SolidWorks, using tools like extrude, revolve, and cut extrude to design precious parts. For the fifth is testing, which is we perform simulations such as finite element analysis to predict performance under load and boundary conditions. We also test the model for stability, durability, and aerodynamic efficiency. Sixth is evaluating, which we assess test results to identify weaknesses in structural design or energy conversion. Other than that, we ensure the model meets the design objectives such as stability and energy generation. Next is modification. We refine the design by improving part dimension or structure the elements based on evaluation feedback. We also adjust features like blade length or tower head for better performance. And the last one is the design iteration. We continuously repeat the step of analysis, modeling, testing, and evaluation to optimize the final wind turbine design. For the finite element analysis, and also known as FEA, I would like to explain to you guys about the purpose of FEA. The definition stated that FEA is a simulation of physical phenomena using the finite element methods, FEM. The usefulness is to provide insight into complex systems and structures, validating and test design safely, quickly, and economically through virtual models. It also enhances designers' intuition for better decision making. And lastly, it's widely used with pre-written commercial code across platforms. So how does FEA works? First is using digital model creation. Model is designed in CAD and import into FEA software. It divided into simple geometric elements. And the second is analysis process, which divide into 3 parts. And the first is pre-process, selecting analysis type, element type, and material properties. Define the boundary and conditions and loads. Second is the process, is performing calculation for each mesh elements. And the last of the third is post-process, which means we review results, try strain displacement to prediction. This is the result after we run a few FEA tests to our wind project turbine. So for the conclusion, we focus on the project goal, which to create a 3D model to show how wind energy is converted to electricity. The steps taken was divided into 4 parts, which mean we made the parts base, rotor shaft, mass, and washer. And the second is we designed the blades using extrude, revolve, and loft tools. We also assembled parts with proper alignment using mates. And the last one is we added visual for realism and ran simple simulation for performance testing. For the challenges that were faced for all of the group members during conducting this project, first is to match the blade size and shape. The second one is to learn new SolidWorks features like lofting and surface modeling. And the third one is to understand terms like parametric modeling and draft angles. About the lessons that we learned from this project. The first one is we improve the CAD and SolidWorks skills throughout this project. Second is we gain a lot of knowledge of wind turbine design. And the third is we solve problems through tutorials, practice, and teamwork. And the last one, the outcomes of this mini project. The practical experience in SolidWorks and turbine modeling. It helped us to have a better understanding of design processes for future projects, and also help us to manage file issues in assemblies. So that's all from us. Thank you for watching, and you can ask any question in the comments. Thank you.